Ya empezó.
Good evening. We're the first team and we're gonna speak of Alan Turing. Uh, Here are the subjects we're gonna handle. And first is who was he? Alan Turing was born on June 23 in 1912 on London, England, and he died in June 7 in 1970, 54 in Wilslow, Cheshire. He was a British mathematician and logical who made major contributions to mathematics, cryptanalysis, logic, philosophy, and mathematical biology, and also to the new areas later named like computer science, cognitive science, artificial intelligence, and artificial life.
Early years. The son of a civil servant, Turing was educated at a top private school. He entered the University of Cambridge to study mathematics in 1931. After graduating in 1934, he was elected to a fellowship at King's College, his college since 1931, in recognition of his research in probability theory.
In 1936, Turing's seminal paper on computable numbers with application to the endurance problems, decision problems, were recommended for the publication with the American Mathematical Logicals. Alonso Church, who had himself just published a paper that reached the same conclusion and Turing's although by different method, Turing's method, but not so much Church, had profound significance from the emerging science of computing. Later that year, Turing moved to the Princeton University to study for a PhD on mathematical logic under Church differentiations. He's completed in 1938. 38.
The Einsteindung's problem. What mathematicians called an effective method for solving a problem was simply one that could be carried by a human mathematical clerk working by rote. In Turing's time, those rote workers were in fact called computers, and human computers carried out some aspects of the work later done by electronic computers. The Einsteindung's problem sought an effective method for solving the fundamental mathematical problem of determining exactly which mathematical statements are provable within a given formal mathematical system and which are not. A method for determining this is called a decision method.
So, looking at this slide, we go back to 1936. This is when two massive figures in logic, Turing and Church, independently solved a major puzzle called the Einsteindung's problem. Basically, they proved that there is no magic formula or effective decision method to solve every problem in arithmetic. It's impossible to create a system that can automatically decide if every mathematical statement is true. The text note that this rule applies even to very simple logical systems, not just complex math. Why does this matter? Well, before this, many mathematicians hoped that they could turn all of mathematics into a mechanical process, something like human computers could just churn out without needing enslaved. But Turing, Church, and the famous Kurt Golden proved that this was impossible. The work showed us the fundamental limits what can be computed or proven.
The Church-Turing thesis is a foundational principle in theory of computation, connecting the intuitive idea of what an algorithm can do with a formal mathematical model. In simpler terms, it states that the class of functions that are effectively calculable by step-by-step mechanical process is exactly the same as the class of functions computable by a formal model, specifically the Turing machine.
Church in this work use instead a thesis that all human computable functions are identical to what he called lambda definable functions, functions on the positive integers whose values can be calculated by a process of repeat substitution. Turing showed in 1936 that Church's thesis was equivalent to his own by proving that every lambda definable functions is computable by the universal Turing machine and vice versa. In a review of Turing work, Church acknowledged the superiority of Turing's formulation of the thesis over his own, which made no reference to computing machinery, saying that the concept of computability by a Turing machine has the advantage of making the identification with effective event immediately.
Enigma and the bomb. The Enigma was a type of enciphering machine used by the German armed forces to send messages securely. Although Polish mathematicians had worked out how to read Enigma messages and had shared this information with the British, the Germans increased its security at the outbreak of war by changing the cipher system daily.
Turing played a key role in this, inventing, along with fellow codebreaker Gordon Welchman, a machine known as the bomb. This device helped to significantly reduce the work of the codebreakers. From mid-1940, German Air Force signals were being read at Bletchley, and the intelligence gained from them was helping the war effort.
It was in the course of his work on the Einstein's problem that Turing invented the universal Turing machine, an abstract computing machine that encapsulates the fundamental logical principles of the digital computer.
Curate Bletchley Park. Turing also worked to decrypt the more complex German naval communications that had defeated many others at Bletchley. German U-boats were inflicting heavy losses on Allied shipping, and the need to understand their signals was crucial. With the help of captured Enigma material and Turing's work in developing a technique he called vampirismus, the naval Enigma messages were able to be read from 1941.
He headed the HUT-A team at Bletchley, which carried out cryptanalysis of all German naval signals. This meant that apart from during a period in 1942 when the code became unreadable, Allied convoys could be directed away from the U-boat wolfpacks. Turing's role was pivotal in helping the Allies during the Battle of the Atlantic.
Turning to uh, the Lydia and July 1942, Turning developed a complex converting teaching he mind Turing's this method in war by orders and verdicts in understanding the Lawrence Zipher matched Lawrence encrypted Herman statics means of high imports the ability of Berg or real his contribution had to the allied was a fault. Daily during daily subjects to United States in December 1942 and at this use military intelligence in the use of gun machines and to share it is current of enigma. With her he has saw the lasted American progress on a top secret switch encrypt system. Later in the war, he developed a sketch schematic debit which he deleted in 1945. Turing was avenged and wrote for his war is war.
The legacy of Alan Turing's life and work did not fully come to light until long after his death. His impact on computer science has been widely acknowledged. The annual Turing Award has been the highest accolade in the industry since 1966, but the work of Bletchley Park and Turing's role there during the cracking of the Enigma code was kept in secret until the 70s, and the full story was not known until the 90s. It has been estimated that the efforts of Turing during and his fellow code breakers shortened the war by several years. But what is certain is that they saved countless lives and helped determine the course and outcome of the conflict.